Yeah, what's the last day of this lecture?
Someone because they're putting their personal needs above the rest. What would you stop doing? What would you stop doing? It's a good thing.
So I unmuted. Now, did I share the screen? Okay, let me check. Okay, it is recorded. Can someone confirm that you can hear me and you can see my computer?
I can hear you and I can see your computer.
Thank you, Leander. Thank you so much.
You're welcome.
All right. Good morning, good afternoon, good evening, wherever you are across the globe. Welcome to Math2P75. How is everybody? Any questions? Any questions, anything? All right, we're almost at the end of the semester. Remember, we have quiz 5 due this Friday. Quiz 6 is due next Friday. And then final exam, July the 10th. Okay, so please mark your calendar and don't mess the dates up. Okay? So today, we'll talk about investment decision. By the end of this lecture, you are going to calculate the discounted value of cash flows. And then that is objective 1. You are going to calculate the net present value, NPV. We are going to use calculator method, formula method, and Excel method. Finally, you'll calculate rate of return. And calculator method and Excel method. Okay. I am using 2 computers. If you have any questions, please type in your questions in the chat area or directly speak up. Okay. I'm sorry, I cannot see your raising hand. You just start with excuse me, so I know you may have questions or comments. Okay. All right. Any questions so far? Now we are going to look at example to calculate the discounted cash flow. An insurance company offers to settle a claim by making a payment of $10,000 immediately or $3,500 at the end of each year for 3 years. Assume money is worth 6% compounded annually. Which plan would you accept? So that is the question. There are many similar questions. For example, do you buy a house or do you rent a house? Similar questions, okay? So you need to make decision between two alternatives. The solution is that you calculate the present value of each alternative, and then you compare the present value. Okay, in this case, the bigger the present value, the more it is acceptable. So you would accept the present value that has a bigger number. Okay. But in terms of to rent a house or buy a house, in that case, when you calculate the present value over maybe 25 years or 20 years, you prefer the less money to spend, then it is preferable. Okay, so depending on the situation, sometimes the more money, the present value, the better it is. Sometimes the less money, the present value, the better it is. So return back to this question. Okay, you have two alternatives. Alternative one, okay, you accept 10,000 today. Okay, you accept 10,000 today. Alternative two, you accept 3,500 for 3 years. Okay, the question is which one would you prefer? So now we need to, alternative one, this is already a present value. What is the present value for this annuity? This three number forms an annuity. Okay, so there are many ways to do it. One way, we can use formula, okay, to calculate the present value of this one. Okay? So this is annuity. The formula is PV. PV equal to PMT. Okay, PMT times 1 minus 1 plus I raised to power negative n over I. So we use this formula, okay, to figure out alternative 2. PMT 3,500, interest is 6% is given. 6% is interest, I is 6%. Over 3 years, so n equal to 3. And you plug in, you get this number here, $9,355.54. So obviously, you would prefer alternative 1 because it provides more cash value. Okay. So this is a formula method. If you use calculator, try to pull out my calculator. Not sure. Try to plug in my USB stick for the calculator. Right. All right, so the same question here. Oops. So let's use calculator to do alternative 2. Okay. Remember, usually you need to set 6 decimal places. Okay. So our quick second format, maybe for this example purpose, I will just set 4 decimal places, number 4, then enter. Second quit. So I have 4 decimal places. Okay. So let's set PY equal to 1. Okay. 1 year you make 1 payment. Okay, CY is also 1 because 7%, 6% compounded annually. Okay, and now second quit, 3,500, that is negative PMT. Okay, term N is 3 years, interest is 6, IY is 6. Okay. Do not forget 0 FV as precaution to clear any previous entries. Last step, compute PV. So you get this number. Okay, agree with our formula method here. Okay, oops, on the second floor here, agree with our number here. Okay, so that is the discounted cash flow. So our decision, final decision, we would choose 10,000 immediate payment. Okay. Example, ACME printers need a new machine. It can be purchased for 8,000. And after 5 years, we'll have a salvage value of 2,000. Or the machine can be leased for 5 years by making monthly payment of 130 at the beginning of each month. If money is worth 5% compounded annually, should you buy or lease the machine? Okay, that is the question. Should you buy or lease the machine? Again, you are making choices between 2 alternatives. Okay, so let's see the alternative 1. Okay, alternative 1, if you buy the machine, you need to calculate the present value. Okay, when you buy the machine, it can be purchased for 8,000. It will have 2,000 as a salvage value after 5 years. Okay, so now you have to translate this $2,000 into today's value. So discount 5 years. And the interest is compounded annually. Okay, so that is the present value if you buy the machine. Okay, this is the cost if you buy the machine. Okay, now let's look at the alternative 2. 5 years, make a monthly payment of 130 at the beginning of each month. Okay, so you use the present value of monthly lease, PV equal to PMT, 1 minus 1 plus I raised to power negative n over I. Okay, because this is a beginning, means this is annuity due, you have to multiply 1 plus I. Okay, so this is formula method, PMT 130, N is 5 years. 5 years is the same as 60 because the payment is monthly. Okay, and the interest. Interest is compounded annually. So for this example, PY equal to 12, CY equal to 1. Okay, so when you use formula, you have to calculate P. P equal to 1 plus I raised to power C minus 1. Okay, and then 1 plus 5% raised to power C. C is CY over PY. You have to calculate P. Okay, and then this formula, you have to use the P. P here. It is not I, should be P. P, 1 plus P. Okay, so the very first step, calculate what is this number. Okay, so I'm going to use Excel to quickly calculate. Try to open my Excel. Just do 1 plus 5% raised to power bracket 1 over 12 minus 1. This is the number I get. That is the P. Okay, this is the P value 0.00407. Okay, and plug in this P value, see 0.00407 into this formula, you get this number. Okay, so this is the formula method, and the calculator method to calculate alternative 2 here. So quick second, quit. This is began, so you have to set began mode. Okay, so first step, set began mode. Second, began. Oops. Second, began. Second, set. Second, quit. See, you have BGN on top right corner. Once your computer is at the begin, you set PY, CY. So second, PY. PY is 12. Enter. Down arrow key. CY is 1. Enter. Second, quit. Okay. And now enter the number. 130 is negative PMT. 5 years, N is 60. And 5% is interest. 5 is interest. 0 FV compute present value. So we get this one using calculator. Agree with this number here. Okay. So this is not this number here. This number here. Okay, agree with this number here. So if you lease the machine, this is the present value. If you buy the machine, this is the present value. So which one would you prefer? So you should buy the machine. This number less than this number here. Okay. Any questions? Right. So buy the machine cost less. That is the conclusion. So that is the discounted cash flow. When the present value of the cash outlays is subtracted from the present value of cash inflows, the resulting difference is the net present value. So this is chapter 16, session 2, net present value. We finished session 1, okay? So net present value. So by definition, net present value equal to money in minus money out. Okay, that is the definition. Present value of inflow minus present value of outlays. Okay, And the result of NPV have 3 situations. NPV could be a positive number when you have a present value greater than the present value of inflow greater than the present value of outlays. When you have present value of inflow equal to present value of outlay, NPV equal to 0. And when you have a present value of inflow smaller than present value of outlay, NPV is negative. So 3 situations. Okay. So now let's look at an example. And this example, pay attention. Maybe similar example will be on final exam. Okay, I'm trying to use different method to do it, and I will also try to introduce calculator. See here we have NPV button, calculator NPV button, and Excel NPV functions. Okay. So this is an important example. Make sure you can independently work out this example by yourself after this lecture. Okay. All right, so a feasibility study concerning a contemplated venture yielded the following estimates. Initial cost outlay, this is the initial cost, and further outlays in year 2 to 5, 225,000 per year. Residue after 20 years, okay, is this one. And then net returns from year 5 to year 10, you have 600 per year. Year 11 to year 20, 500 per year. The question is, should the venture be undertaken if the required return on investment is 15%? So that is the question. Okay. To answer this question, you need to calculate NPV. Okay, what is NPV? Or you calculate the present value for money inflow and the present value of money outlay. Okay. So first, we take a look at formula method. Formula method. So for formula method, I'm going to move this over here. Actually, I copy the question here. This is the same question here. Okay. So we try to figure out my Excel. Try to use my Excel. It's here. Okay, this is the example. Okay, we try to figure out what is the present value of inflow, what is the present value of outlay. Okay, because the NPV equal to PV in minus PV out. So we need to ask what is the value of PVN, PVIN, what is the value of PV out? Okay, so first let's do the PVN. Okay. So the money inflow. Okay. So this is money inflow here, net returns. So this is okay, inflow. Year 5 to year 10, 600 per year. Okay, so 600 per year. 600 per year. This is one part of money inflow, and the other is 500,000 per year from year 11 to year 20. And it also has residue. After 20 years, this machine, this project has 625 as residue for money inflow. 3 part. I'll try to use here. Money in, that is the good thing. I'll just use red color. Okay. Maybe use green color. Okay, this is money in. Use green. So this is money. No, why still give me the red? Try to use red, green. Okay. So this is money in, money in, money in. Okay. For money in, this money 625 is after 20 years. So in 20 years. Okay. So what is the present value of this one? Oops, which one? 6, this is 5. It is this one here. Okay, so you can use Excel the present value formula. So the formula is here. So equal to PV, interest rate is 15%. Okay, over 20 years. So this 625 is future value. Okay, and you figure out this one here. So this number corresponding to here. What is the present value for this one? And now figure out what is the present value for 600. So the formula is here. Okay. And this part has 2 components. Okay, has 2 components. One is, remember, one is this is year 5 to year 10. One is what is the annuity here. Okay, so the annuity, the present value for this annuity, and then this present value discounted to here. This is today. Okay. That's why in this formula, this part is the annuity. So PV equal to 15%. Okay, 15%. Try to copy this formula here. 15%. It is 6 years. From year 5 to year 10, it is 6 years. And each year, it is negative 6,000. So this is this formula. And then discounted to here. You multiply 1 plus I. Remember the general formula, PV equal to FV. 1 plus I raised to power negative n. Okay, the regular compound interest formula here. And then you plug in this formula. So in this formula bar here, I combined 2 formulas in one to figure out the present value for this number. Okay, I showed you the formula here. Okay, and next, similarly, we calculate the present value from year 11 to year 20. From year 11 to 20, you have 500 per year. 500 per year. Okay, and this is a 10-year period. Okay, so the formula, the number is here. Again, I combine 2 formulas. One formula is the present value of the annuity. See here, present value of the annuity. The other is discounted to present value. Okay, so make sure you understand this, okay, and you can figure out by yourself after this lecture. This number comes from here. Okay. So those three parts is the money inflow. One is the residue. The other is year 5 to year 10. Okay, next one is 11 to 20. So this is 1, 2, 3 here. You plus 1, 2, 3, this number together, you get this number. Add these three numbers together, okay, you get this number. So this is all money inflow. I use the green color. Next, let's look at money outlay. Okay, I'm going to use red color. Does not change. Okay, try to change the color of my pen. Money outlay, you have initial cost. This is money outlay, okay. And then you have for year 2 to year 5, 225 per year. This is outlay, just two parts. Okay. So this is today cost. Okay, this is this money. And then how do I figure out the present value of this number, this annuity? Okay, you use present value formula. So equal PV 15%. It is 4 years. Each year it will cost 225. So this is the formula here. Okay. Does anyone else seeing a frozen screen? Anyone see the frozen screen? Everyone is okay? Humble said it's good. It's okay for him. Benjamin, frozen screen. Can you see screen here? Are you okay, Benjamin, now? Okay. All right. So the money outlay has two parts. Okay. You add these two parts together. This is a money outlay. These two numbers, add these two numbers, you will get this number, money outlay. So money outlay has two parts, 1, 2. This is 1, 2, money outlay. Okay, item 1 plus item 2, you get money outlay, money out. Okay, and here you have money in. Okay, you use money in minus money out, you get the net present value. So in this Excel, it is B8 minus B4. You get this net present value, $14,373. Okay, any questions? So this is a Excel FV function. Excel FV function to calculate PV. And the PowerPoint slide also give you the formula method here. Money, it is different. The formula method, money in, they put this as money. So this is the formula method in this slide. Okay, that calculated money in, money out. I did a little bit differently. I added the residual value. I consider this one as money in. I put it in money in my calculation. Okay, but it comes with the same result. Because this residue, if you consider it money out, there is a negative sign here. It is the same as the residue. If you consider it as money in, you have positive sign. Okay, any questions? All right, so now I'm going to introduce calculator method because this calculator has the NPV function here. NPV, okay, NPV function here. To do this NPV function, I will reorganize data in Excel format here. This is the data I reorganized. Okay. So I'm going to make this font bigger. So this number is the initial cost, negative 1,300,000. Okay. And then 225 from year for 4 years. So this number happened 4 times. 225, this is the cost. If it is the cost, you use negative number. Okay. And then you have benefit. 600 from year 5 to year 10. You have 600, so happened 6 times from here to here. 600,000 happened in 6 years. So this number happened 6 times. Okay. And now from year 11 to year 20, 500,000 per year. So it happened 10 times. This 5,000 should happen 10 times. Okay, I will put it here, 500,000. Okay, so this 500 happened 10 times. However, there is a residue. Residue in the last year is 225. So here you have 625, oops. 625,000. This is the residue. So what happened in last year? What happened in last year, you have to add 500,000 with the residue. That is the net return in last year. Okay, so last year it is not 500, it should be the sum of 500 plus 600,000. Okay, so last year should be this 500,000 plus the residue value. This is happened last year. So last year you have net return 11,025,000. So this is the last year. Okay. So 1,125,000. This is the last year. Okay. So again, take a look at why arrange the last year. You have to add the residue value for last year. Residue value for last year. Okay. All right. So once you figure out this, everything is ready. You can use calculator here. NPV function. Oops. Where's my Excel? Try to see if I can see. Okay. I can use one computer just to check. I have another computer check the message. Okay, great. All right, so now put this over. Now you ready for calculator, NPV function, NPV in calculator. So to do that, you press the CF function, cash flow, you see the CF, Okay. Maybe I will get rid of the begin mode. Usually it is the end unless it said the begin. So second begin, second quit, no, second begin, second set, second quit. So this is the normal setting. Okay. So to use the calculator CF cash flow function and then NPV. So quick CF, you get CF0. That is usually is the initial cost. Initial cost. It is strongly suggests this is many students have the problem. Every time when you use the CF function, before you enter number, make sure you click the second clear work just as a precaution to clear any previous entry. Remember this. After you press CF button, you should press second clear work, this one here, CEL, the bottom left corner. Okay, and then you enter initial cost, 1,300. And this, all the number I will omit the 30. It will come with the same number. Okay, because we are calculate the net at the end. I will add the, maybe I will on safe side, I will just add this number. So this is the initial cost outlay because it is cost, it is negative number. Okay, then enter. So initial cost. Now use the down arrow key, C01. Okay, C01 means the first cash flow. It is a negative 225. So you type in 225,000. This is a negative number. Press enter. Okay, this is a cash flow 1. Down arrow key. F represents frequency. How many times this 225 happened? Remember I showed you how many times this number happened. Here, this number happened 4 times. Okay, this number happened 4 times. So frequency is 4. Enter. Down arrow key. And the next number is 600,000. So 600. Oh, did I press next button? Yeah, I pressed the negative 225. Okay, just double check. Next cash flow is 600. 600,000. Okay, 600,000. Enter. Down arrow key. And this number occurred how many times? 6 times. Okay, you count here 6 times. So you type in 6. Enter is the frequency. Then down arrow key. Next number is 500,000. 500,000. And this number occurred, if you count here, 9 times. Okay, so enter. Down arrow key. This number occurred 9 times. Enter. And down arrow key. Next cash flow is 1125, 1125, and then 30. It is this number. Okay, this is the last year. What happened in last year? Enter. Down arrow key. This number occurred only 1 time. Okay, so you entered all cash flows, and next you press NPV button here. NPV button, and it will ask I. I means interest. Okay, return is 15% is given. So you type in 15 without percentage. Just type in 15, enter. The last step. After enter, you press down arrow key. You have NPV. Then you press CPT. CPT compute. See, this number agree with my Excel number here. $1,373.12. Okay, so this is the calculator NPV function. Okay, and then Excel. If you have all of this number ready, using the Excel. If you have all of this number ready in Excel, you type in here, quick cell A. Oops, I undo it. I did something wrong. So you type in equal NPV. Rate is 15% in Excel. You have to type in percentage, 15%. When you calculate value, do not use the first initial cost. So start with A2 until the last one. Then my mouse is too sensitive. And then you plus the initial cost. This is the way you use Excel NPV function. Okay, press enter. See, you get this number. And this number agree with my calculator method here, agree with my FPV function here. So the formula is here, I showed you. All right, so any questions? So this example, make sure you can do it individually without looking at these solutions, because final exam will have similar question. I don't limit what method you use. Use whatever method you feel comfortable. All right, so shall we take a break? Come back at 7 o'clock. We are going to do internal rate of return, IRR. Okay, so I'm going to stop recording and then start recording again. I stop recording.